Morning, friends. Last class we discussed something about computer-aided process planning. There are two types: generative process planning and variant process planning. Variant process planning, in the sense we have to retrieve the existing process planning schedule and modify according to our drawing or our requirement, and we can use it. So that is variant process planning. Generative process planning, while generating the CAPP model itself, we have to decide and also the process plan should be generated newly. Okay, so we have to generate according to the model, CAD model. So the process plan, for generative process plan, it needs a lot of modules. So it refers that module, the data available in standard that will be retrieved and that are used to generate that process plan. Okay, so these two are major category in process planning, that is called as computer aided process planning. So why we need to go for computer aided process planning? What is the advantages over the manual process plan? So in manual process plan, what happened? It depends on the individual skill. Okay, so some experts, they may be knowing about all the process in thoroughly, so that they can plan as per the schedule. Okay, so they will give one process plan, and some other persons having a little experience, they will give some other process plan. There may be some correlations in between these two. Okay, so it is very difficult to identify which one is best. So that difficulties and also that difference may be there always in manual process planning. But in computer aided process planning, all the parameters are defined. If that parameters is defined, that is the process plan will be automatically generated. A standard process plan will be generated. It depends on the parameter, not the operator who runs the software. Okay, so the computer aided process planning gives the unique and also standard process plan wherever it is required. Okay, it depends on the parameter or the data that are entered, not depends on the human experts. Okay, so the standard process plan can be easily generated. So what are all the softwares available for computer aided process planning? So by using this software, you can select either retrieval. In the database, you can retrieve the document or retrieve the process plan, or you can generate your own process plan according to the component or according to your component. So here some of the process planning softwares are designed. Okay, CAPP, MI Plan, MI Turn, MI APP. That is some of the company or some of the softwares provider, they provide CAPP software or process planning software for their products. Okay, so these are all some of the standard applications available in market. So if you want, you can use this software for your process planning development. So some of the process planning softwares we are going to discuss now. So the first one is that CAPP, that is computer aided process planning. You know what is mean by CAMI, computer aided manufacturing international. So this is one type of software that is provided. Okay, so the coding language in this software is Fortran. So that is olden days, initial days, the computer aided process planning was introduced by using Fortran language. Okay, so by using this code, if you enter the parameter, according to the parameters needed, you can develop your own process planning software. So the process plan, in the sense, you have to plan the material requirement plan, manufacturing resource planning, and what are all the raw materials that are available, that is inventory requirement. Okay, and when the product is to be completed. So to complete that product, how much resources are required? To plan everything, we need a chart. Okay, we need a handout. So everything will be produced by using this software. Okay, so this is one software. Initially, that is in olden days, this software is used for producing computer aided process planning. By using this, we can code, and also part classification, that is classification and coding system is done. According to that coding system also, here the process planning is obtained. Okay, so based on the coding system, we have some database. By using that database for a particular component, if it is coded in a particular part family or for a particular part family, what will be the standard process plan that can be easily generated. Okay, so this is the process planning system that is followed by that CAPP process planning system. So in the task we have some of the databases that are available. So in the database, standard sequence file, in which sequence the raw material should be sent out to complete the product. Next one, the operation plan. So to reduce the cycle time or to improve the productivity, how we can utilize, okay, which process we can choose. So that standard process suggestion has been given as a data file. Okay, application program. So which program, which machining programs we can use, either CNC or we can go for a conventional machine or some other advanced applications. Okay, so that suggestion is given. And part family matrix file. So this we have already discussed. To generate or to create a part family or to create a coding system for the component, we need a part family matrix file. Retrieve the coding of the existing part, edit or modify it according to your component. Create a new part family file. So according to the part family file, so that will be stored in the database. Okay, and by using the standard databases available for your component, retrieve the or search the relevant file available in the database. If it is available, retrieve it, modify it, and generate the process plan. If it is not there, according to the new component, new file will be generated. So there are two files. One is generative and another one is a variant process planning. By using any one, we can generate. Okay, so nowadays the combination, the hybrid method is used in all type of process planning software. So if it is not there, the new files will be generated. Okay, so that file will be stored in that database. Okay, so that will be retrieved in future for editing. So these are all the operations that will be suggested by the standard process plan. Retrieve it. Finally, the process plan will be generated. Okay, so that process plan generated. Okay, and the generated process plan will be stored in the database for future. Finally, process plan chart will be prepared. That is, root sheet is prepared. According to the root sheet, that final process plan will be ready. So according to this process plan, you can identify to complete the particular component how much material is required, how much manpower is required, which type of machines are required, how much time is required to complete that particular or the entire operation. So everything can be identified by using this process plan. Okay, so this is the simple layout of the computer aided process planning software. Of course, this is a general software plan. This is common to all. So this is a simple method that is given by CAPP. Okay, Computer Aided Manufacturing International Process Planning. So the next one is the Plan and MultiCap. So these two are related process planning software. Okay, so this also relevant to the first one what we discussed earlier. So this is generated by the Organization for Industrial Research. So both Plan, okay, and the MultiCap is a advanced version of a computer aided process planning when compared to the old one, CAPP. So this is a MultiCap system. So in this, we have to generate. We have a designed model or modeled component we have. Okay, for that component you have to search for the available process plan. Again, the process are same. We have to search the database whether the standard process plan is available or not. If it is available, retrieve it and edit according to that standard database is available. If it is not there, you have to generate new one. Okay, so here create new or retrieve if it is already there. if there's already available component can be used without editing, you can use it. So directly you can finish it and you can use it. The retrieval part itself without any modifications, you can generate the process plan. Otherwise, you have to go for some modifications. Okay, some of these standard files are available that will be helpful for retrieving, editing, creating parts or part family, and generating standard process planning. Okay, so these are all some of the supporting documents required by using the files. Okay, this is the layout by using which the process plans will be generated. So some of these standard files are here. Okay, standard part files which gives the part family details, security file which gives the security or which gives which is used to protect the file, and standard text file. So some of the descriptions about the part family that are stored there. So by using this, we can, these are all the standard, these standard files would be used to retrieve the component or retrieve the part file or retrieve the process plan which was generated by using the software. Okay, so finally all will be taken and edited, and finally that will be generated doing some modification or doing some editing operations. Okay, so finally the rule sheet will be generated, that will be again stored. Okay, and if you want to edit, rename, delete in future, you can use it. Finally, if you want to re-edit it, you can use it. Okay, so this is a simple layout how the process plans will be generated by using this MultiCap process planning system. So next one is a CAPP and AutoPlan. So this system is a generative process planning. It is not a variant process planning. So a detailed process plan will be generated by using this process planning software. Okay, so only you can generate. So there is no part file available. So for a modeled component, you know the procedure how to generate from the starting stage to final stage. According to the raw material or modeling steps, the process plans will be generated automatically. Okay, so by using this software. So this is a generative process plan. So you can generate a new process plan according to this software. Next one is AutoPlan. So this is also a generative process plan. This will be automatically generated. So the plan will be generated automatically. So like the previous one, AutoPlan. So this also can be used in conjunction with the CAD model software. Okay, so if you have a model software, by adding in as an add-on, you can use this software to generate the process plan automatically. So that it is called as AutoPlan. So only thing you have to set the parameters or give the parameters. So based on that, the process plans will be automatically generated. So there are 4 major modules are here. So first, group technology. The parts should be grouped in a particular part family. According to the part family, some standard files will be available, or you can generate your own process planning. Okay, the graphical planning, that is while doing the modeling stage itself, the process plans will be generated. Okay, in a step-by-step process to complete that entire operations. While completing that entire model, you can generate or you can create a process plan automatically by using this software. So the software, according to the instructions given to model that component, the process plans will be generated. According to the instructions, the generative process planning, it generates the process plan according to the component. Finally, it optimizes its own plan. Okay, it generates according to your modeled structure. Then it sets or it optimizes the process which is required. Either if it is required to manufacture the 2 processes in a one machine, so that can be possible by re-editing the final process planning. Okay, so that process optimization is done at the end of the stage to reduce the lead time or the manufacturing time of the component. Okay, so this is another process planning. So next one is a computerized production process planning. So this software is suitable only for cylindrical parts, so that too used in a lathe component. Okay, so that is mainly focused on cylindrical component to make or to manufacture or to machine that particular component. The process planning will be automatically generated. Okay, so this is another process planning software. The final one is a TIPS, that is totally integrated process planning system or software. Here what happened, all the models, CAPP model software and the material requirement planning, manufacturing resource planning, route sheet preparations, everything will be interrelated. Okay, so finally one chart will be prepared according to that model. So like AutoPlan, this is also some kind of automated process plan generator. So according to the instructions given, you can generate your own process plan. So this is also called as a generative process planning. Okay, by using some logical process, the process planning is created here. So what are all the advantages or features available in TIPS? It has a modular structure. So because it is a generative process planning, it can be integrated, so that it is called as a totally integrated process planning system. It can interact with the CAD system according to the CAD procedure. The process plans would be generated automatically. So it looks like an AutoPlan, and it allows for interactive surface identification. While modeling itself, by interacting or by identifying the model, the surface, their process plans can be modified. So final optimization is also possible, and also knowledge description. It contains process descriptions and knowledge descriptions. So what is meant by process and also knowledge description? Some of the process description according to the model, how it is manufactured. So that will according to that the process plans will be generated. In knowledge description, by using which machine or which process, the entire operations would be generated with a high quality or high accuracy. Okay, so based on these two, it optimizes which one is required or which one is suitable for the particular component, that will be automatically generated. So that is the main features for this software. So this is the structures that are given as a flow chart for TIPS. Here some of the standard databases available. Okay, so by using that database for a particular component, for example, surface marking, it refers to that particular module for helping it retrieve the data. Using that data for your component, that process plan will be generated. And process selection module, it refers process file. And process parameters module, it refers the parameters. What are the parameters required for a particular component? Either it is a rectangular block, or either it is a cylindrical part, or it is a regular shape or irregular shape. It refers all the standards file. According to the standards that are available, by using that parameters definition, it generates own report. So finally, it generates a report as a plan. So finally, the process plans will be generated. Okay. So that's all about process planning. So there are a lot of softwares available, that is user-friendly software. All are user-friendly software. According to your CAD system, according to your component requirement, you can choose any one process planning software. Okay. So normally where we are going, or where we are using this computer-aided process planning, the fully automated plant. Okay, and also in mass production stage, we are using this process planning. And also the company which focuses on more component, okay, more variety of components if they are manufacturing, then we need a process planning software. Okay, because they need to procure lot of different variety of raw materials, and also to manufacture that component they need a different variety of manufacturing resources. To utilize the available resources, to utilize the material available or available material effectively, they need a process plan which should be satisfy or which should save the raw materials and also manufacturing or production time, okay, and also the productivity should be increased. So this process plan software is not suitable for a single component, and also the batch quantity which is less than 1000 or 10,000, okay. So if it is a mass production, then this software would be very reliable, and also it is more suitable for mass production company, okay. So this is computer aided process planning. So next one is a FMS. FMS in the sense flexible manufacturing system. So in the manufacturing system, why it is called as a flexible manufacturing system? Suppose you have a workshop, okay, which consisted 10 variety of machines. By using that, we can generate one type of component. Okay. Suppose you are focused on generating the same or different variety of component. Okay. You have the facilities, but you need to modify the workflow accordingly. Otherwise, what happen? You can't manufacture the component effectively, or you can't produce the component within a time. So the flexible manufacturing system gives the flexibility to arrange your workshop or arrange your machines according to your requirement. For a first component, the 10 machines is required. For second component, if only 6 machines are required, while making the second component, flexibly you can arrange your machine shop. Okay, either you can change the machines, or either you can change the routing or conveyor system, or the material handling or work handling system. So that is called as a flexible manufacturing system. Flexibly you can change or you can modify the manufacturing resources that are available, then it is called as a flexible manufacturing system. So this can be obtained by using computer controlled equipment. Okay, either you can change the machinery, which are all controlled by means of a central computer or a controller, or by changing the material handling system. It may be palletizing, or by using a AGV. Okay, by using automated handling equipments, or by integrating robot center cell, you can modify. Okay, and also ASRS system. By implementing ASRS system, ASRS in the sense automatic storage and retrieval system. For a particular component, what are all the tools available or required, that will be retrieved from the ASRS system. If it is not required, then that will be automatically stored at that particular places. So by using these facilities, you can implement FMS. So that is called as a flexible manufacturing system. So these are all the subsystems or FMS. This is automated material storage, that is ASRS system. This is controlling of machine tool and also equipments. Okay, logistic control, everything. So this would be integrated both. And also the palletizing system, washing system, that is in a different machines or different workstations, how you can transfer by using our handling devices. Okay, so these are all the subsystems required to implement FMS. The scope, you can assemble the components easily. Okay, and in small chips oriented devices, electronic devices, microcontroller, semiconductor component, so that are manufactured by using this FMS system. Plastic injection molding, sheet metal fabrications, welding, textile machinery manufactured, and also nowadays in automobile component, okay, component assembly workstations, we are using FMS. Okay, so in a work plant, if one type of car is assembled, then the same can be modified to assemble another variety of car. Okay, because in the market continuously changes have been generated. Okay, if one model is outdated, if you want to modify some other thing, your system can be modified, should be modified. Okay, so then only that can be used in future. Okay, otherwise the facilities which is available cannot be used in future after 5 years or after 10 years. So that can be modified. So that in every automobile assembly stations, the FMS are implemented. So these are all the scopes of FMS. So where we can implement FMS? So that is a big question. Here, if the variety is more and also the volume of the component is less, okay, we can't implement FMS there. Okay, so here general purpose machine, that is by using a conventional lathe or conventional machining machines. Suppose you have a 1 or 10 component or 100 component, you have a time, so you can have a variety, but the volume is less, so you can use any general purpose machines to manufacture that. Okay, suppose if there are variety, you have a lot of variety, okay, but the volume somewhat increased, you can go for CNC machines. Okay, if the variety is less and also the volume is more, you can go or you can upgrade to FMC. FMC in the sense flexible manufacturing cells. The cell consists 4 or 5 machines. According to the variety, you can modify the cell or you can modify the machining center. Okay, the cell in the sense it consists only 4 or 5 machines, not more than that. So that is called as the flexible manufacturing cells. If the variety is somewhat less and also the volume is somewhat in moderate, okay, so in those cases we can go for FMS. Okay, suppose the variety is still less, the volume is more, you can go for a special purpose machine. So that is a dedicated machine for a particular component. Otherwise, if the less variety, mass production system, you can go for a transfer line. Transfer line will be automatically transferred to each machine for a particular component. That is only for a mass production. By using the transfer line, you can generate one particular operations throughout the manufacturing system. Okay, so the FMS comes in the category variety is medium level, volume is in a medium level, so that it is suitable. So you can't implement FMS here, large variety and also less volume, because the implementation or the cost to implement the FMS is more. Okay, you can't implement FMS here, okay, because it is a mass production. Over 10 months or 11 months, you can have the demand or you can have the order. So you can't. There is no need to modify your FMS. So that implementing FMS here is waste of the time. Okay. Here, if you implement, if the variety is more according to your variety, you can modify your work cell or work system so that it is beneficiable or the productivity can be increased. So this is one of the FMS layout, how you can use or how you can integrate it. Okay. So this is a storage system, that is ASRS. In the sense, you have a rack kind of thing. Automatically, the component or part which is required, tools for jigs and fixers or some other supporting component which is required for manufacturing, that will be stored automatically here. Okay, whenever you need for a particular component of particular operations, that will be automatically retrieved or automatically stored by using a computer. If you enter the part name, in which the location of the parts you can easily identify. Okay, and also if you give that, so that will be coded by means of a computer, that will be stored in a particular place. How we are saving files in your computer, like that the components are stored automatically. By using a computer, you can retrieve the component. So that is called as the ASRS system. From the ASRS system, there is a control computer. By using that control computer, you can select the tool or components which is required. By using a PLC control, okay, you can control everything. So the supervisory computer, by using PLC, you can retrieve the component. Okay, you can operate CNC lathe by using the retrieved component, by using the program, by using PLC. Okay, it can control variety of machines. It can control CNC machining center. It can control CNC lathe. Okay, to fix the job or to transfer the job from machine to machine, we can use the transfer line or conveyor system, or AGV. You can use automated guided vehicle, or you can use robot. Okay, robot can be used to fix or transfer or move the materials which are required. So this is one layout by using this is a FMS layout. This can be modified according to your requirement. Here two machines are there. For next variety or second variety, if you need 5 machines, according to your convenience, you can arrange 5 machines. Okay, according to the location or arrangements or structure of the machines, you can modify the layout, you can modify the work handling system, everything, and you can use it for the second variety of component. Okay, for third variety, if you need 10 machines, you can have a circular kind of thing. You can arrange it accordingly. You can use a AGV to transfer one machine to another machine. Okay, so that is possible in the flexible manufacturing system. Types of FMS. FMC, normally the machines are limited. Okay, FTZ, that is only for turning operations, so that is called as a flexible turning cell. Automatic FTZ consists a robot for loading or unloading the component, and automatic tool change system. The tool can be automatically changed, and also the changed tool can be stored automatically and also retrieved from the ASRS system. In the automatic tool changers, having a tool head can be changed, a tool adapter can be changed, everything. Okay, automatic head locking system, automatic head changers, everything. Okay, so these are all the supporting systems available in FTC. Flexible transfer line. So transfer line in the sense to transfer work between machine to machine. Either it may be a conveyor system, or either it may be a belt system, anything. Okay. Finally, it is a flexible machining system, that is FMS. Okay, so it starts from FMC, where the variety is more and all the volume is less. We can slightly increase. Okay, according to the volume, you can increase the level. So that is called as from FMC to FMS. So benefits of FMS: greater variety. Okay, and also greater flexibility. Okay, so that you can meet the customer requirement. Okay, and also shorter through time. Okay, so that is the output time gets reduced, so that you can easily meet out the customer's requirement. Okay, and better utilization of the resources. Resource utilization is more in FMS. So these are all some of the benefits that are available. So that cycle is explained here, the benefits of FMS. Okay, reduce the space, quick response, higher utilization, improved quality, ability to change over, so everything. So these are all some of the benefits that can be obtained using FMS system. Major elements of FMS. FMS can be implemented for sheet metal operations, and also FMS can be implemented for machining also. Okay, variety of machining. Either it may be a machining center, or either it may be a turning center, or either it may be a special purpose machining operations. So that can be implemented for any variety of machines. So here FMS, in the sense, it is a manufacturing system which consists all. You may be having CNC machines, okay, DNC machines that are controlled by means of a central computer. Here that will be controlled only the machining operations. Here from one machine to another machines, how we can transfer the work piece. Okay, This machines different fixers required. For second machines, fixer size or fixer requirement may be varied. So according to the second machines, all the equipment, supporting equipments will be retrieved, that will be automatically fitted. So from the second machine to third machine, according to the third machine's requirement, that can be automatically generated. So here the operator is not required. Only the job of the operator is they have to assist the operations which are handled by the entire system. So here the main important operations would be carried out by using a CNC machines. Okay, so all are controlled by means of a computer, that is called as a DNC. So CNC, DNC implementation along with the work handling system, material handling system, okay, and also the tool handling system. So everything is integrated together so that you can get the flexible manufacturing system. And support system, after making or at the end of the system, you might be having some measurement system which is used to measure the component, and tool presetting. So according to the workpiece requirement, tool presetting, job presetting should be done automatically. Okay, so that is possible. And also tool regrinding, repair and maintenance. So you have to give time for maintenance. Suppose if it is a flexible manufacturing system, if it affects the 9th machine, so entire production should be stopped. Okay, so frequently you have to maintain the system. So you have to allot some time in a day. If the components are running 20 hours, the remaining 2 hours to 3 hours you have to utilize for maintenance, so that the reliability or the ideal time of the machine should be reduced. Okay, so replacement of the broken or worn tool, so that should be offline, you can made it. Okay, because you have a tool library, you can have that tool changers, tool heads, everything available. If anything is damaged while making operations in the system, another one is rested. In ASRS system, you can change and store it in that place. So like a buffer storage, you can keep it as a spare. Okay, so that the quality of the workpiece will not be reduced. So these are all the major elements used in FMS. The another important thing is the material handling system. This will be used to transfer the workpiece from one machine to another machine. Okay, and also to transfer throughout the workshop. So either you can use automated guided vehicle to transfer from one machine to another machine, or transfer lines, or chain conveyor system, and also automatic storage and retrieval system. So here somewhat manual operations are also there. In somewhat automated retrieve and storage will be automatically controlled by means of a central computer. So both is possible in ASRS system. So we will discuss this ASRS system in detail in next class.